some parts, and I want to ask this calculator related question though, which I believe is question 5 in your book. Okay, so um, in your textbook pages, hold on, sorry. Yep. Yeah. Um, I so first this is along the x-axis. And um, obviously this is the y-axis, and you're right. Like that means that it will display from negative 20 to 40 along the x-axis. What does the 10 mean? No worries. So it means like what it's counting by. So negative. Exactly. Negative 20 to 40, and then it's counting by tens. So this is negative 10. Blah blah blah. Okay, got it. And so then naturally along the y, what does that mean with what we have here? Exactly. Negative 5 to 5, counting by ones. Exactly. Good. All right. So that's all there is to that. Um, sorry. Hold on. And then yeah. So 6 and 7 and 8, I'd like you to answer. Yep. Yep, exactly. Okay, cool. And generally, if you're given the equation, how do you find x-intercepts and y-intercepts? Yeah, sure. But I'm saying if you're given an equation, so if I give you like y equals 2x minus 2, or in the different form, if I gave you 2x minus 4y equals 10, let's say, in either case, how would you find the x-intercepts and the y-intercepts if the equation is given? Yeah, after doing what though? For x-intercepts, you yeah, exactly. For x-intercepts, you set y equal to 0 and solve. So the x-intercept in this form would be like 2x equals 10, so x equals, what is that, like 5? And so since we made y 0, that would be 5 comma 0, blah, blah, blah. But the point is for x-intercept, you make y 0, and for y-intercept, what do you do? Exactly, there you go. You make x 0. Okay, good. Otherwise, from the graphs, it's easy to tell. Okay, does it say what equation 6 to 8 10? So like that's fine. Okay, yeah. So this is my bit, like my insert into this lesson, right? Having looked at everything, which is like the absolute value function. If you're asked to graph it, is just a v. So this is like y equals absolute value of x. Um, so this is with no changes to it. So given that, what is the equation of like, because in part it says like to go from the parent function, so this is the parent absolute value function. So then in number 6, what would be the equation of that function showed displayed in number 6, given that the parent again is what I just drew, y equals absolute value of x being a v centered at the origin. What is number 6? Y equals what? Go ahead, sorry. Yeah. So the way I like you to think of that is it's this V graph I drew shifted to the left by 2. So that would be y equals absolute value of x plus 2. Now, the key thing here is for left and right, it's the opposite. When it's shifted to the left by 2, it's x plus 2. If it were shifted to the right by 2, it would have been y equals absolute value of x minus 2. Does that make sense? Yeah, for up and down, it's literally whatever the number is. So, for example, I'm going to draw it in green. If we're looking at a V like this, and again, the original absolute value V we know is not changed because when I go one to the right, I go one up, blah, blah, blah. So same in green. I'm saying the inclination has not changed. All I did is literally move it down 3, let's say, where that number, on the number line, the V occurs at 0, negative 3. Then what would the equation of this green absolute value function be? Exactly, the absolute value of x minus 3. Now, what's very important you distinguish between these two, and I know you know how to do this now, is like when you're putting the x and the number inside the absolute value, that will be like for left or right, and it's the opposite, which is when you want to move to the left, it's plus 2. When you want to move to the right, it's minus 2, or whatever amount you need. But when it's north and south, which is when it's a vertical shift, it's literally exactly as it is. The number is outside the absolute value, and it will be minus 3, plus 3, whatever it is. Like, obviously, plus 3 being going up 3. Now, equally cool and important to know is this, which is these transformations are universal, meaning that if the parent function, instead of the absolute value function, if instead of that I had this, which is the parent parabola y equals x squared, right? Like, so if it was y equals x squared, well, similarly, if I ask you what is y equals x squared plus 4, then this should be up, move it vertically up 4 so that the vertex here is at 4. And obviously minus 4 would be down 4. But just like the absolute value, if you want to shift it left or right, you have to put the number together with x inside. And so say like I have x minus 3 all squared like that. Well, now, again, the parent parabola is y equals x squared, but this time I have shifted which way if I'm looking at this here? Huh? Sorry, yeah, so what kind of a shift is exemplified by this here? Yeah, compared to the parent, but compared to the parent parabola, which is right here, I'll highlight it in green. So compared to this, which is just y equals x squared, what have I done in this one? Y equals x minus 3 in parentheses squared. Not quite. Like this parabola above right there is y equals x squared plus 4 because it's just literally moved up 4. Up and down is just adding the number or subtracting the number. But when it's inside the parenthesis like this, for the parabola, which way do you think? It's just like the absolute value situation. When the absolute value and the number are inside together in the absolute value, that's left or right. So when x minus 3 is inside, right? Like then that's going to be left or right. Which way? Yeah, and moreover, when it's inside, just like the absolute value, when it's inside, it's the opposite. First of all, it's left or right, and second, for left or right, it's the opposite. So if it's minus 3, it's to the right 3. So the correct graph for this, if we're to graph it, would look like this. It would be like right here, where the x-intercept, the vertex here, is at 3 comma 0. Does that make sense? Okay, I want to summarize this real quick. So, 1, y equals absolute value of x and then plus 5 to y equals absolute value of x minus 1, 3, y equals x squared plus 7, 4, x minus squared equals x plus 2 squared minus 3. Okay, so listen, there are two parent functions involved here. One of them is for the absolute value ones for 1 and 2, the parent absolute value, which is just the v centered at the with the vertex being at the origin. So this is what I just drew is a portion of y equals absolute value of x. And then for 3 through 5, the parent function is y equals x squared. My question to you is, how are 1 and 2 related to their parent y equals absolute value of x? Comment about both. Yeah, but what I'm asking is like, if I graph them, 1 and 2, how are they transformationally? Like, as shifts of this parent absolute value, how are they shifted? Start with 1. When it's inside the absolute value. Yeah, sure, no worries. The plus 5 is inside the absolute value together with the x. So what did we say about that? Which way does it shift you? Huh? Up would be absolute value of x plus 5, like that. That would be up 5. But, yeah, sure. Go ahead. Huh? Okay, it's okay. So the distinction to make is when it's outside, the number is outside the absolute value, it's up or down by whatever amount. So it's plus 5 here. So if I were to graph this here, then I would see it as a vertical shift up 5 from the V that I drew in blue that was anchored at the origin. Does that make sense? Yeah, but if it's minus 5, I'd go down 5, blah, blah, blah. But when it's inside of the absolute value, so when the number is like that, then it's a shift to the left or right. And so my question, yeah, and which way is it? Uh-uh. When it's inside, remember, when it's left or right, it's the opposite. Yeah, so absolute value of x plus 5 would be to the left 5. So that would be like this here, if I were to graph it. Does that make sense? Okay, that's for 1. Okay, what about 2? What do you mean? No, no. When it's outside, you don't make it opposite. It would just be down 1. Yeah, so it would just be a V like I drew just now. Okay, don't worry, it's okay. And again, what I'm saying is these are general, which is like when they apply to quadratics, much the same way they do for absolute values. So for number 3, our point of reference is like a quadratic, the parabola y equals x squared. And that, the parent parabola, just like the parent absolute value, is anchored at the origin, where the vertex is the origin. So it would look like this. So this is y equals x squared. My question, 3, what would that look like? In other words, as a transformation of y equals x squared, what happened in 3? Up how much? Yeah, up 7, literally. And if it was minus 7, that I would be down 7 over. What about in 4? The point, kiddo, is the point is just like 1, it's inside. So then it's got to be left or right.
So, but normally it would be, um, was it less, but doesn't change the,
Yes, so it's going to be to the right 7. So if I were to graph 4, it would look like this, where this number right here on the vertex would be 7. Does that make sense?
yeah.
Yeah, again, what you're doing is you're asking, and the absolute value or the parabola, you're asking is the number inside or outside? If it's inside, it's got to be left or right, and it's the opposite. If it's plus, it's to the left. If it's minus, it's to the right. If it's on the outside, such as 2 or like 3, then it's literally like what the number says, but up or down. Does that make sense?
Yeah.
Okay, 5. What's happened in 5?
Well, inside the current, so that would go down by 2, but then it goes down by 3 again, so it's down by 5.
Inside, is it down? Up and down? If it's inside, is it up and down? Huh? Go ahead. Yeah, there you go. So it'd be at the vertex would be at -2, -3. The number outside, literally as it says, go down 3. But what's inside is left or right movement, and it's the opposite. So it means to the left 3. So the vertex would be right here, and it would look like that. So as a transformation of this parabola anchored at the origin, it's basically the same kind of inclination, only it's to the left 2 and down 3. Make sense?
Yeah.
Okay, this is like probably like the most important part of like everything that's represented in all of your worksheets. So that's why I wanted to start here. Okay, now to keep my promise, and let's do what we had said, which is let's go over the questions in the order that you want me to go over them. Or let's start with the ones that gave you trouble, as you said.
Okay, yeah, I'm just looking at that. I guess, okay, so we did 1 through 8. So I guess I'm looking at 235. Um,
Okay, sorry, real quick. What's the equation in 7 and 8? If I said tell me the equation in 7, what would be the equation of that parabola?
37.
Yeah, you're given the graph of a parabola. What would its equation be?
Well, I guess when I'm parabola, I just think this is exponential for parabola. So,
That's right. But just think of it as we did just transformationally. So this would have been just y equals x squared. So in 7, what's happened?
so like, well, I switched to x stars.
Don't overthink it, kiddo. So this is y equals x squared. So what's happened in 7 transformationally?
We went down.
Yeah, exactly. So it's y equals x squared minus however many units you went down. 1, 2, 3, 4. So y equals x squared minus 4. Over. That's it. Okay. What about an 8? What's the equation of 8?
It's just a straight line.
But it's a vertical straight line, so go ahead.
So x equals 5.
There you go. Good. X equals 5. Don't doubt yourself. Like, I think like maybe like, that like our recent discussion on that one. Like, don't lose confidence, kiddo. Like that's the only part that I'm seeing that you did really well in Algebra 1. As I said, we did it very quickly over the summer, but you're smart and you know what you're doing here. So, like, give back your confidence because this is not hard. Okay, anyway, what did you say you wanted to do next?
I guess 15 through
Yeah, gotcha. So, and there I think you were assigned the odd numbers. So,
Yep, I was assigned the odd numbers, but that's simply because the odd numbers all the answers that are in the back of the textbook is just an answer in the back.
gotcha.
But I was to do like
No problem. So you tell me, like, since we're gonna take your lead on these ones, you tell me which ones gave you trouble. Let's start there,
um
or whichever attracts catches your attention.
I'm trying to not like show
No problem. Take your time. It's okay.
um I mean I don't know, I was just trying
Say that again.
I used to do
23. You said.
yeah.
Okay, sure. Real quick, like I know you know how to do these linear equations, and they're in the other worksheet also. So maybe because they're represented in a couple of places, I will be convinced. The next one looks harder, but it's not. None of these are hard. So if you do this one successfully, then I'll be convinced you're good. So this is 21. So what would you have done here?
Well, I guess something like that first. I would say, by anything like this to get rid of the denominator on that first step.
Oh, gotcha. So you're on 23. Yeah, sure. Good. Sorry. That's smart. Go ahead. Equals x plus 6. That's exactly what I would have done in this case. So you multiply everything by 6. I'm writing on the board, by the way. Talk to me. What happens when we do that?
So, seven on the left, that would become the left hand, the 23 will cancel. And then it would be just x plus 6. So,
Oh, sorry. Real quick. You're right. Everything you said was great on the left. What does it all reduce to on the left? 2x plus 2 on the left? Or 2x times 2?
oh, times, yeah, no,
It's okay. And so then what's that?
4.
Uh-huh. Yeah. Slow down when you're going too fast like that, but don't worry. Like, you're good. And then where to from here? It's pretty straightforward.
So then that means 4x equals x plus 6.
Mm-hmm. And where to from there?
So an x away from the
There you go. Yeah, exactly. 3x equals 6. Divide both sides by 3. X equals 2, right?
Yeah.
Okay, great. Now, yeah, so we skipped over this one. It's okay. This is 21 on that page. So talk to me about what you would do in 21 to start.
Okay. Start by here.
Yep, that's exactly what I would do. Excellent. That already lets me know that you know what you're doing on this problem. But I will write a second step and um, say what I would do next, which is I'm sure what you would do. Put this together with this, right? Like, that's what you would have done next? Okay, great. So that would give you 7x plus 5 equals, and what would it turn into on the right side?
On the right side. This is, will that just be 7?
X plus 3. Yeah, and then what would you do next?
So then I guess what I would do is I would take a 7x away, which should be 5 equals 3, which is 4.
Exactly. So, like in the other worksheet, he had you label, or she had you label, like, equations. This is the one that would be called inconsistent, right?
Yeah.
Okay, and it might have been like, if it was if it turned out to be 7x plus 5 equals 7x plus 5, then this would always work. And I don't know what label she'll give us, she gave you for that, but we'll look at it just important to note the inconsistent ones and that we talked about it. Great. All right, so what's next? Which one do you want to do next?
Uh,
Okay, sure, no problem. Um, just so that I am, because I'm a paranoid person, I'm also like satisfied about where you're at. Let's actually do, if we go a little bit over it, time is on me, but let's actually do 7 over x minus 5 plus 2 equals x plus 2 over x minus 5. And this is 29. So talk to me about what you do on 29 here.
so I guess because this fraction already has the same denominator,
Mm-hmm.
then just use the um, what is it, 7 over x minus 5 to the right.
Sure, I could do that. So one option is like if I did that, then I would write what 2 equals. Talk to me.
Equals x plus 2 minus 7 over x minus 5.
Yeah.
That just becomes x minus 5 over x minus 5.
Yeah. So 2 equals x minus 5 over x minus 5, and then what would you do after that?
So that was 1.
Yeah, exactly. Good. That's what I would do there. I would reduce x minus 5 over x minus 5 to 1. I'm sorry, you were saying?
That means it's a solution.
Exactly. This is another one of the inconsistent ones. We keep randomly picking them. Okay, the other approach, kiddo, is like much the same way that you did 23, like clear the denominators. If we want to clear the denominators, I should multiply both sides by what?
X minus 5.
That's right, exactly. Good job. And if I do that, then we give it here, we give it here, it multiplies the 2 crucially. That's the one worth highlighting. The rest, I figure you figured. So when x minus 5 multiplies the 7 over x minus 5 on the left, that would just give us a 7. And then we'll have plus the 2, as I said, worth highlighting, is also multiplied by x minus 5. So we'll get plus 2 times x minus 5, like that, right?
Yeah.
And then on the right, it would just be an x plus 2, fair? Okay, now then we have 7 and then plus 2x minus 10. I believe that's what it is. 7 plus 2x minus 10, right? Yeah. Equals, and then, yeah, equals x plus 2. Got it. And so then we get 2x minus 3. That's the 7 and the 10. Yeah, equals x plus 2. And so then we would have plus 3, and then minus x. We can handle doing both. So we're going to get x is equal to 5. But then x equals 5, notice, I can see like all along I'm like kind of stuttering unusually I don't know if you've noticed, but you're perceptive, so you probably did. Like my whole point is like, wait, it looked like we're destined for a different answer than what we got when we did it your way. But no, we're getting to the same place because x equals 5, this answer doesn't work. Why not?
Because
You wrote the name down on the worksheets.
yeah, I wrote
X.
x equals 5.
It's an extraneous solution.
Yeah, but I just said 1.
That's true. That's true. But you're not. This is not like a graph. That you're not looking at it as a graph of a. Sorry, as a graph of this equation. You're looking at it as just a number. X equals 5. The number here in this equation doesn't satisfy this equation because it makes the denominator 0. If it makes the denominator, yeah, it's okay. It's if it makes the denominator 0 anywhere, it doesn't work. And the only times you have to check if you have extraneous solutions, such as x equals 5 in this example, is if like your denominators have variables like x minus 5 and yada yada. Make sense? Okay, cool. All right, great. Um, so then 30 again. This is just for my paranoia's sake, but like it's fine. Like if we take a little bit of extra time, it's fine. It won't kill us. It's worth the prep. So minus 1 over x plus 1 equals, and so this is 30. And I believe the one you wanted to look at was 31. We'll get there. Just this one in passing by. So this equals 2 over x squared minus 1. Talk to me about how you do this one.
So,
Mm-hmm.
x squared minus 1 or x minus 1 times x.
So what should I do to get common denominators?
Multiply,
What should I multiply? Yeah, multiply this one by what?
minus 1 times x plus 1.
Yeah, so this one x plus 1, numerator and denominator, right?
Yeah.
And this other one? Hmm?
X minus 1.
Exactly. This one, this time, x minus 1 times x minus 1. Now, so then I would have x plus 1. Now that on the left they have the same denominator, namely, what denominator is it?
X times 1. X minus 1 times x plus 1.
Which is the same as?
X squared minus 1.
Yeah, there you go. Great. We like that because we see an x squared minus 1 on the right. And the question should always be well enough written that, you know, this kind of conveniences should appear if you're doing what you're supposed to do correctly. So kind of use it as a guide also as you're going through problems. Now, on this part, the crucial piece is that there's a minus sign here. So that needs to be distributed to this x plus 1 that's going to go in the numerator on that part, right?
Yeah.
So it's going to be minus x plus 1. So then now it's pretty simple. What's going to happen here on the left? What happens here in the numerator, to be specific?
Well,
A 0 or?
well, x plus 1 minus itself.
But it's not minus itself. So this minus sign, yeah, after I distribute it, it makes the x negative, but it makes the 1 positive.
Right. So,
Yeah. 2 over x squared minus 1 equals 2 over x squared minus 1 is what it say, right? And so then the solution is all real numbers.
Yeah.
Yeah, all real numbers actually except for 2 real numbers. What 2 real numbers must we exclude? Yes, x equals all real numbers except, yeah, x equals 1 and x equals negative 1 because they both make the denominator 0. And so then both the left and the right side would be undefined quantities. Always don't forget, like, you know, I know we already said this, I'm intentionally repeating myself. Always don't forget on problems like these, which are like solving rational equations where you have denominators with variables and numbers, like in the end to check that like it doesn't make your denominator 0, and if it does, to toss it out from the solution set, right?
Yeah.
Okay, cool. And so then finally, the one that you'd said we should look at, and that's 31. So 31 is, I think we're appropriately focusing on, like, you know, the things that are worth a lengthy discussion, because there's a lot of stuff that we could um, just quickly like discard or understand that we don't have to worry about it. Okay, so 8 over and then it's x squared plus x minus 6. Talk to me.
Um, so I just noticed the least common denominator x plus 3 x minus 2, which is the same thing as x squared plus x plus 2.
Exactly. Beautiful. That's a great observation. Continue.
I did not realize that denominator on the fraction denominator and the fraction on the right is the same thing as x plus 3 x minus 2.
Mm-hmm.
But up to the
So you're saying let's write the right side is 8 times x plus 2 times x plus 3 times x minus 2?
sure.
Sure, we can do that to start. Go ahead.
Then multiply the other fraction by x plus 3 x minus 2.
Yeah, exactly. Do the opposite, right? For this one, multiplied by x minus 2 over x minus 2, right? And the other one by x plus 3 times x plus 3. Got it. And then what?
Okay, so from there, on the, from there to
Yeah, exactly. And we could probably at the same time distribute the constants in front, right?
yeah, so it would be 5x minus 10
Mm-hmm.
plus x plus 3.
Yep.
So that would become 6x minus 7.
Yep. Over
Yeah.
over what?
X plus 3 x minus 2.
Yep. X plus 3 x minus 2 equals
I have to 8 over x plus 3 x minus 2.
just 8, right? On the right side in the numerator?
Yeah.
Yeah. Okay, good. And then from here?
So from there, I guess you want to get rid of the denominators, right?
Yeah, exactly. And so you could write multiply x plus by x plus 3 times x minus 2 on both sides, right?
Yeah.
Yeah, and that's an obvious step. To be quite frank, you could just ignore the denominators because since they're the same, all you need to ensure is the numerators are equal. But and even though you know that that's the case, just go through the extra step of writing multiply by x plus 2 times x minus x plus 3 times x minus 2 on both sides on your paper, just so your teacher sees it. But it's pretty obvious that if the denominators are the same, then you need to only concern yourself with equaling the numerators. But go through it anyway, okay?
Yeah.
Okay, so then after writing that, you'll next write 6x minus 7 equals 8, and then where to from there?
No, and that's supposed to
Yep, so 6x equals
15,
mm-hmm.
equals 6%, which is 5 over 6.
X equals 15 over 6, which is 5 over 3. And don't forget to take this number and plug it in to make sure that it doesn't give us a 0 denominator, right?
Yeah.
Yeah, now it's pretty obvious without plugging it in that it doesn't make this 0, it doesn't make this 0, therefore it doesn't make their product 0. Yeah?
Yeah.
Okay, cool. Alright, good. Very well done here. Like, I was happy with the way you were able to handle this. Now, I guess, well, no, I don't think we need to do, like, I was gonna say, like, 33, but 33 is pretty obvious, right?
Yeah.
Yeah, it's much like obviously the right side factors is x times x plus 2, and it's in a weird way an easier version of 31. So even though it comes after it, so we don't need to do that. All right, cool. So there are a couple of word questions. I know that from the worksheet bunch that you have, like from the earlier bunch you sent me, like one of the things that you have to do was English to math translation. There'll be like a certain quantity, like is I don't know, like has five more blah blah blah, and you have to like translate that into algebra and solve the algebraic equations. Now, since there are a couple of word problems at the tail end of this second page of your book you sent me, did you want to look at those those word problems? I'm talking about 36 or 37, and yeah, what do you say?
Okay, so I'm looking at the textbook page right now. I mean, honestly, um, why doesn't do something else in the textbook? I think I'd rather just go back to the worksheet instead.
Yeah, gotcha. Like you know, of a similar mind. I just wanted to like double check with you real quick before we go to the worksheets. Before we move on, so you're saying let's move on to the worksheets, right?
Yeah.
I'm with you now. Before we move on, in 35, what would be your first step in 35?
Um, yeah, sorry.
It's okay.
Okay. Yeah. So, for 35, I guess my first step would be to, I would say, factor the denominator of the second fraction.
Yep. I would also, if you have like just a number chilling at the end like that, like -1, I would add it to both sides. So look on the whiteboard real quick. So, like first of all, like what you said is exactly the correct answer. That's probably the most important thing to do is to factor the guy in the middle, right? But I would also simultaneously on this exact question on or on a similar type, take the constant that's by itself to the other side. So it will become a positive 1 on the right. Obviously, if it were instead of -1 on the original question, if it were +1, then when I move it to the right, it would become -1. In any case, do that because then, like what you said about factoring, this will help. But at the same time, moving the constant to the other side, since the other side was just a number anyway, well, that allows you to like work with like an easier quantity on the left side. Does that make sense?
Yeah.
Okay, great. Like so, just wanted to point that out since yeah. Okay, all right. I'm ready to go back to the worksheets. So on the worksheets, let's see. Um, sorry. On the first page, like there's really nothing, right? Like and yeah, there's really nothing. Like you know, there are certain points that are on the x-axis or on the y-axis, and you wrote like for example E is on the negative y-axis. So keep in mind things like that, but like that's it. Okay, so unless you have a question on the second worksheet, we talked about the like Windows stuff on the calculator. Otherwise, you're just graphing stuff from tables, so it's not a big deal. So and yeah, unless you have questions, I don't think there's anything on the second worksheet. What do you say?
All right, right.
Okay, cool. Third one. Okay. Well, yeah. So like you know, we talked about the transformations earlier, like and so there are like which is how do you look at shifts and whatnot. So if you have absolute value of x, again, just to graph it, it's a v where the v is anchored in the origin. If I put a negative outside of the absolute value right here, what that will do is it will flip it over the x-axis. So it will look like that in blue. Does that make sense?
Yeah.
And as I said, these transformations are universal. So if instead of y equals absolute value of x, you start off with y equals x squared, again, this would be like this time a parabola, a U shape, but with the vertex still anchored at the origin. If again I throw a negative in front of it, what that'll do is like it will flip it, it will mirror it over the x-axis and it'll look like that. Fair?
Yeah.
Okay, so in that first part, that's what you were tasked with. Okay, so then otherwise, identify x-intercepts and y-intercepts. We talked about that at length, so we don't need to talk about anything else from this third worksheet. Stop me if you feel we should. Okay, cool. Now on 4, like I really like this question. It was fun. It was nice. You already put a check mark to the right graph. Can you explain to me your reasoning? Like, or I'll lead you with questions. So according to the description, why is the graph like going up until it starts coming down?
So I guess I guess that yeah, because as you go down, as you go more time goes down, goes up, and then bottom up another is the opposite.
Exactly. Go ahead.
If you're just sliding along a level strip, that's not going to be a climb or anything. So it's a straight line and you stop, you will be a zero.
Exactly. Beautiful. So like I am literally repeating myself intentionally, but like yeah, like your speed, which is along the y, increases if you're going downhill, and then if you're going uphill, your speed goes down. As you said, if you're like on a flat surface, your speed doesn't change. Like so, it's horizontal, and then you have to eventually come down to 0 at a stop. So you go down that graph. Makes perfect sense. Okay, got it. Now, anything else on this page that we should talk about? Okay, cool. So then the next page. On the next page, sorry, it's solving linear equations, and the only one I was curious about is the last one. And 1 and 2, all I'll say is like, make sure that you distribute the minus sign that's in front of a parenthesis to both quantities inside the parenthesis. But that's something that you know really, really well. And nice, like those little circles you were drawing. I guess you were bored for a second. What is it? I'm watching, Julia. No, I'm kidding. Um, and and 4, like there's a little bit of order of operations. Write it down if you need. PEMDAS, parenthesis first, exponents, blah blah blah. But like all of these are solving linear equations. So unless you want me to stop at any of them, I'm happy to move on. What do you say? Okay. All right. So 11 and like yeah, basically like this whole page, this next page starting with 11, there are things that we practiced to death. That's actually what we spent on the most in your book pages. So I don't think we need to go over any of them, except I would like a little bit of elaboration on what you did on 7 as an insurance for me. So go ahead, talk to me about 7.
Okay, so for 7,
Mm-hmm.
I think both of the denominators.
Sorry, say that again.
Both of the
Exactly. Like so, you wrote earlier least common denominator and whatnot. Like so, earlier you knew to multiply things like x minus 2 times x plus 3, but here there's only x plus 3, and what's underneath the 9 is really a 1. So the least common denominator is at just x minus 3. So you multiply both sides by x minus 3. But then that means that, sorry, I know this is stuff you know. I'm intentionally repeating myself. But anyway, what that means is on the left side, you just get rid of the denominator, that's x minus 3. On the right side, make sure you distribute the x minus 3 to the 3 right there and to the 9 right there, right? Yeah, that's why, like on the right side, well, 3 over x minus 3 times x minus 3, these guys cancel. But then for the 9, it's 9 times x minus 3, and that's why it's 9x minus 27. You get that part, right?
Yeah.
Okay, cool. Alright. Like, hold on. So next is, well, yeah, so, like, it's elaborately built, right? Like, the question at the top, like, where, like, your teacher says y1 is equal to 1 over x plus 4 plus 1 over x minus 4, and y2 equals, so, like, he names them, the two equations y1 and y2, and then says set them equal, but it's basically an elaborately, like, constructed, but identical to a couple of questions that we did from your book pages, right?
Yeah.
Yeah, the only note I would say is at the very end, do not forget to plug in your answers into the denominators, once again, to make sure that you don't get extraneous solutions. And here are, like, names that, quite frankly, were, like, new to me, like labeling stuff. So all real numbers, like, there wasn't one that we've come across, except for the linear equations that don't have denominators. I suppose those count. But remember, like, there was one where I asked you in the end, what are you gonna exclude? And you said plus or minus 1, which was the correct answer. That was not all reals, because, well, we're excluding plus or minus 1. So in other words, like, even if it's just two numbers that you have to throw out, it doesn't fall in the all reals. But the linear equations, the ones that don't have denominators, well, they have all reals. So there's that. And then conditional is like finite. So that's if you have one solution or two solutions. And then the inconsistent ones we've talked about enough. And it looks like in example 10, you had to look back at all the equations you solved and label them. So you had all the practice you needed as far as labeling. Next page. Okay, so the next page, this is what I was talking about, like English to math translation. So talk to me about how you feel on this. Huh?
Sorry.
It's okay, no worries. Take your time.
Okay. So, football.
Mm-hmm. I mean, you tell me which ones do you want to go through? Do you want to go through all of them? I'm happy to go through all of them if you need.
No, I mean, I'm looking at, like, it's a fun service, so I'm trying to find something that's, like, not as
Yeah, like, I mean, I can point you to it. So so, and two. Explain two to me. Read it and explain. Go ahead.
I mean, obviously,
Yeah, exactly. I really liked how you were like, obviously X is a number. No, that was adorable. Okay, yeah. So 20%. I mean, it's great that you know as a fraction it's 1/5, but if on a different percentage that's not so obvious to you, just write the number over 100 and then reduce all the zeros. So 1 0 goes, and then you get 2/10. But 2/10 is 1/5. And so 1/5x is 20% of x, and then since it was decreased, that's why there's a minus sign, right?
Yeah.
Yeah, exactly. And then 3, so I'm happy, like, I'm more confident about, like, your total mastery of these now that you explained yourself on why you wrote 1/5 minus 1/5 x. Anyway, on the next one, it says 60%. 60%, once again, like, you knew that was 3 out of 5. But if you didn't, right, 60 over 100, and this is just me being, like, totally paranoid, but yeah. Anyway, what's new? What's new there? Cancel the zeros, and that gives you 6 out of 10, and then reduce a little bit more, and you get 3 out of 5. But you already knew, so good. Okay. And then 4, read it and just, like, sanity check, like, talk to me that you know it. Yeah, sure. No problem. Yeah, so 4, read it, and then just, like, so I'm happy. Tell me how you got there.
Okay, so,
Yep.
That and
Go.
have a good for the stuff like or somewhere that you know.
Yeah, exactly. They're a system of equations, so you can get y by itself in the second equation and substitute for y in the first equation and the unused equation with what you found y was in the second equation, right?
Yeah.
Yeah. Did I go over that too fast, or you're good? Yeah, and notice that in the first equation you could have written y equals x plus 26 because you don't know which number, x or y, is the bigger of the two, but it didn't matter.
Yeah.
Okay, cool. And then next page is, yeah, talk to me about, like, do you need help on 5 or 6?
I'm just reading the question.
No problem.
No.
Okay, cool. And then the next one is, sorry, 7, 8, and 9. What do you think? Tell me whichever one of them you need help on. Mm-hmm.
I'm just reading them.
No problem. Take your time. You're good with these?
Yeah.
Okay, no problem. I'm here if you need me. Okay, so sorry. What about the next bunch, like 1 and 2?
One I think I'm good
Mm-hmm.
with.
No problem. Yeah, exactly. Just know 9% is 0.09, blah blah blah. But like, you're good. Okay, I think you're good too.
Yeah.
Yeah, no worries. And then, oh yeah, these ones I was looking at. So it's solving for a variable that on these bunch, and sorry, hold on, solving for a variable. Yeah, I don't know which of them interests you. Like, I'm happy to do as many of them as you want. First of all, like, let me know if you have a question on 3, but otherwise, 4 through 8. Yeah, let me know which of them interests you.
I think it's okay. When I'm but I like I still don't get one.
On 8, you said?
Yeah.
Yeah, sure. So you're solving it for C, right? Like, okay. So, um, P equals C plus MC. And you're solving it for C, right?
Yeah.
Gotcha. So now, like, you're very, very good at factoring. Like, you're always good about, like, finding GCF. And especially here, because you're supposed to solve for C, if you have a similar expression like this, like factor. So on the right side, if I factor out a C, I would have to write C times what?
Um. Well, wait. Why are you multiplying? First place?
Yeah. Why am I multiplying in the first place?
Yeah.
Because I want like C times something, so that I could divide by something and get C by itself. And I see that C appears in 2 places, so I know I can factor it out. If I want, I could put C times 1 right here. So when I factor out a C from the right hand side, I'll have C times, what should I write in the parentheses?
I'm sorry.
Yeah, sure, no problem. So on the right hand side, if I factor out a C from the 2 terms, I would have to write C times, what should I put in the parentheses?
If you multiply C by
1, 1 plus m. Because, like, when I distribute the c, well, I need to get back that c, so I need the 1 to be there. And then when I distribute the c over there, I'm going to get mc.
Yeah.
Does that make sense?
Yeah.
Okay.
Um,
Go ahead. No, go ahead.
well, I suppose, so you would do that for all, like, the ones, right? Like, where the C and like two spaces like that? Or
Exactly. And 2 or more places. Exactly. Like, I'm going to write down my own equation in a second that will have a similar thing and ask you to solve it. But, of course, then now that I've got c times something, since my goal is to get c by itself, I'm going to divide both sides by that something, right? So on the right, I'm just going to get a c. On the left, I'm going to get p over 1 plus m. Fair?
Yeah.
Okay, cool. So here's my question. So let's say I have 2v, and then 2vt is equal to, and then it's 3x, and then minus v, and then plus, um, sorry, uh, let's see, 4tv. And my task is, um, no, like, sorry, 4tx, let's say. My task for you is solve this for, um, solve this for x.
Okay, so guess I guess the first thing I would do is I would swap the two B and the three X in place.
Okay.
That X is on one side.
Yeah, so, yeah, I would move this guy to the left because then that would give me things that have x's. Exactly. But most importantly, you said the right thing, which is the variable I asked you to solve for here is x. So you want to group things that are about x together. Okay, good. So, sorry. So I would write 3vt and then plus v, having added this v to both sides. Does that make sense?
Yeah.
Equals, on the right, I'd have 3x plus 4tx, and then what?
So I just divide everything by two, right?
Divide everything by t? What do I want to solve for? Yeah, and now that we've got only things that have x on one side, we should factor out an x
Okay.
on the right side. So when I factor out an x on the right side, what do I get? X times what?
3 plus 4.
And that's right. And then on the left, you get 3vt plus v. I don't care that this got v and t on the left. I'm doing a much harder question than any that you're going to see. But anyway, like, all we care about is the variable that we're asked to solve for, that we got everything involving it all on one side, and just that. We accomplished that in our second step. And then we factored it out, and it's obvious now I'm going to divide both sides by 3 plus 4t, right?
Yeah.
Okay, great. And so then that gets me x is equal to all this junk on the left. I would try to factor and reduce, but like, not much there's to factor and reduce. Okay, kiddo, like, I don't want to take up too much of your time, but I definitely also want to be like, make sure that I give you a fair shot at getting an A specifically. Like, I feel that by the time we're done, you're able to get 100, or you have all the tools to get 100. And so I want to summarize, like, one bit of something that we talked about earlier. Sorry, like, real quick. So, uh, sorry. Um, and actually you should start with 2, 3, and 4. Again, you're starting off like I'm asking you about parent functions. So y equals absolute value of x and y equals x squared. And again, recall y equals absolute value of x is just a v anchored in the origin. And if you were to plot points, the kind of points that are on it is 1, 1, negative 1, 1, 2, 2, and so on. Make sense? And negative 2, 2, and so on. Okay, yeah. So starting with absolute value of x, what did I do to get y equals that in 2? Transformationally, go ahead. What happened to get this?
Well, I guess so you could use the absolute value for this one.
Yeah, so starting with this transformationally, what happened, and what I have here, and I will box it in green. This here, what's happened to it from this here, from the v of the absolute value of x only?
Does absolute value one
Huh?
or is equation two? Are those absolute value?
Yes, those are absolute value bars. So you're comparing it to the parent absolute value of x.
So you try to define four, but because it's on the inside way, it's opposite, right?
Yeah, and which way is it shifted?
Right.
Yes, exactly. When it's inside, it's left or right. It doesn't matter if it's absolute value or squaring the quadratic. If it's inside, it's left or right, and it's the opposite. So what happened is, if I had to really precisely graph it, this is 4, comma 0. So it would just be a V where the vertex is at 4, comma 0. Does that make sense?
Yeah.
What about 3?
Well, I mean,
This time, yeah, sorry. This time we're going off of. I apologize for interrupting. This time we're going off of. Clearly, we're going off of y equals x squared, which is a parabola this time, right?
yeah.
Yeah, but it's still like anchored at the origin and so on. So it's the parent parabola. So from the parent parabola, what did you do to get 3? Go ahead.
So, I guess now you added two
Mm-hmm.
to add.
Mm-hmm.
So again, inside the parentheses, you would change it to root left.
Yes, good, good. So it's negative 2. The v of the parabola, or the u shape of the parabola is going to be now with the vertex at negative 2, 0. Because as you said, it's inside, so that's left or right, and it's going to be to the left since it's the opposite when it's inside and it's left or right, right?
Yeah.
And then 4.
So, I guess you're part of my house, now, not
Exactly. It's a parabola, but this time it's moved down 5. So this is minus 5 right there, yeah?
yeah.
Okay, great. And 1, what do you think about 1? It's first of all, our baseline now is the v, the absolute value, since, well, 1 has absolute values in it. But I did 2 things to it. What are those 2 things that happened?
You add the value within the absolute value part, and then you type in negative.
Yeah, exactly. So what the inside plus 2 is going to be, well, a left or right, and it's going to be to the left since it's plus, right? It's the opposite. But then the minus sign in front, that, remember, flips you over the x-axis. So what that means is our final product is going to look like this. It's going to be flipped down because of that minus sign, and then it's to the left too because, okay, great, wonderful. I'm very, very happy about what you gave me back here. Okay, but I want to, before we say we are done, I want to do number 7 from the solving for variables, and I will write it, and you don't need to look at your paper. I want you to look at the board and give me instructions, and it's b equals f over S minus V, and you're solving for S. Okay, so talk to me.
Um, so I think that I will multiply everything by S minus 3 to get rid of.
Yes, beautiful. Anytime you have denominators, that's the first thing you should try and do is like get rid of the denominators if you could help it, and which should always be possible. But yeah, excellent start. Good. Go ahead. And then
Um,
this is what we get first of all, right?
yeah.
Uh-huh. And then go ahead.
So, from there I would distribute with
Yep, exactly. That's what I would do. Good. So distribute the yep, and then
the S minus 3 equals F, so then, I would divide everything by V. So,
what are you trying to solve for? Yeah. I suppose you could divide everything by b here, but perhaps maybe we should have done it like at the middle step. Um, since you're trying to get s by itself, like right now, this part doesn't have an s in it, so move it to the other side.
right.
Okay. So how could I do that?
Um,
Yeah, exactly. Add bv. Again, like whenever it's these variable things, you had like the most important part is the how to start it. Like otherwise, it's like isolate it. So only keep things that have it. Like and if they don't have it, move them to the other side. That's the name of the game. Okay. So bs equals bs equals f plus bv, and then what's next?
then from there I would divide everything from V, so S, equals F over
Facebook. Exactly. No. Okay. So like all right, I'm satisfied with this, and I'm satisfied with our prep. I know that there's a last page, so look on the last page and let me know if you have any questions on the last page. If not, then we can consider this prep done. You don't have questions on the last page?
I don't think so.
Okay, cool. All right, work carefully. Like, look out for like things like extraneous solutions. If you're feeling you're rushing, like slow down a little bit. Like that didn't happen very frequently. Like once maybe, but otherwise, like, do you feel very prepared?
Yeah.
Okay, cool. If you decide to practice later and any questions come up, I'm a text away. Otherwise, go in confident, work carefully, and you should do really well. Okay, kiddo?
Okay.
Okay, have a wonderful night.
You too.
Uh huh.
Thank you.
You're welcome. Bye.
Bye.
Bye.